In this section of the MECH study group, we will be covering plumbing and pipe fitting. Approximately 14% of the questions asked on the MECH exam will be on the area of plumbing and pipe fitting, which means that about 14 of the 100 questions will be about installing pipe, cleaning waste lines, plumbing fixtures, filters, softeners, water systems, medical gas systems, steam delivery systems, and pumps. We are going to be covering the following tasks that come directly out of the MECH test preparation manual: how to read blueprints for plumbing, how valves operate and how they are constructed, plumbing codes, various methods of making piping connections, how to use sewer augers, how to size various piping materials, how to read fluid pressures, the letter codes for copper thickness, how backflow preventers are used, and the basic function of plumbing piping, including vents, traps, potable supplies, and various others. The first area of knowledge to understand is how to read blueprints for plumbing. Some plumbing fixtures are shown on the screen. Some of the most common symbols you will find include water closets or toilets, drinking fountains, and showers. Some additional symbols can also be seen on the screen, and on the right side can be seen pipe fitting symbols that will be integral in reading and understanding plumbing drawings. And on this next slide, you can see the symbols for valves on the right side of the screen. Valves are covered extensively in this presentation and are likely covered in the MECH exam. Typically, you can find the plumbing fixture schedules on the first pages of a set of prints and will likely appear in a table format similar to what's shown here. Plumbing floor plans can be extremely complicated or quite simple depending on the building and the systems involved. In this example, a patient bathroom is used. Note that many of the symbols from previous slides are used here. The next section we will cover is how valves operate and how they are constructed. A valve is a device that regulates, directs, or controls the flow of a fluid, meaning gases, liquids, fluidized solids, or slurries, by opening, closing, or partially obstructing various passageways. In an open valve, fluid flows in a direction from higher pressure to lower pressure. A valve is not only a flow controlling device, it also regulates the flow and controls the pressure. Some of the most common types, and those that we will be going over specifically today, are ball, gate, globe, butterfly, and the check valve. Globe valves are widely used in healthcare. You can see the basic makeup of the valve here, with the plug being connected to a stem, which is operated by a screw action using a hand wheel in manual valves, but can also be actuated pneumatically and electrically. A ball valve is a valve with a spherical disc, the part of the valve which controls the flow through it. The sphere has a hole, or a port, through the middle so that when the port is in line with both ends of the valve, flow will occur. When the valve is closed, the hole is perpendicular to the ends of the valve and flow is blocked. Ball valves are durable and usually work to achieve perfect shutoff even after years of disuse. They are therefore an excellent choice for shutoff applications and are often preferred to globe valves and gate valves for this purpose. They do not offer the fine control that may be necessary in throttling applications, but are sometimes used for this purpose. Gate valves open and close pipes by lowering metal gates across them and are named after this for a good reason. Most valves of this kind are designed to be either fully open or fully closed and may not function properly when they are only partway open. Water supply pipes often use valves like this. Operation of a butterfly valve is similar to that of a ball valve, which allows for quick shutoff. Butterfly valves are generally favored because they are lower in cost to other valve designs, as well as being lighter in weight, meaning less support is required. Unlike a ball valve, the disc is always present within the flow. Therefore, a pressure drop is always induced in the flow, regardless of valve position. A ball check valve is a check valve in which the closing member, the movable part to block the flow, is a spherical ball. In some ball check valves, the ball is spring-loaded to help keep it shut. For those designs without a spring, reverse flow is required to move the ball toward the seat and create a seal. The interior surface of the main seats of ball check valves are more or less conically tapered to guide the ball into the seat and form a positive seal when stopping reverse flow. A diaphragm check valve uses a flexible rubber diaphragm positioned to create a normally closed valve. Pressure on the upstream side must be greater than the pressure on the downstream side by a certain amount, known as the pressure differential, for the check valve to open, allowing flow. Once positive pressure stops, the diaphragm automatically flexes back to its original closed position. A swing check valve is a check valve in which the disc, the movable part to block the flow, swings on a hinge or trunnion, either onto the seat to block reverse flow or off the seat to allow forward flow. The seat opening cross-section may be perpendicular to the center line between the two ports or at an angle. Although swing check valves can come in various sizes, large check valves are often swing check valves. The flapper valve in a flush toilet mechanism is an example of this type of valve. Tank pressure holding it closed is overcome by manual lift of the flapper. It then remains open until the tank drains and the flapper falls due to gravity. In this next section, we will be covering plumbing codes. Designated as an American national standard, the Uniform Plumbing Code, or UPC, is a model code developed by the International Association of Plumbing and Mechanical Officials, or the IAPMO, to govern the installation and inspection of plumbing systems as a means of promoting the public's health, safety, and welfare. The UPC is designed to provide consumers with safe and sanitary plumbing systems, while at the same time allowing latitude for innovation and new technologies. The public at large is encouraged and invited to participate in the IAPMO's Open Consensus Code development process. This code is updated every 3 years. In most cases, drain pipes must slope at least 1/4 inch per running foot, but some codes may require that vent pipes slope 1/8 inch per foot. Always check your local and state level codes to ensure you are following the correct requirements. Be sure to use special drain fittings, such as a closet bend, so wastewater can flow smoothly. Local and state plumbing codes will have specific fitting requirements for different fixtures. Use purple primer, as shown on the screen, when joining PVC pipes. Pipes that are glued without primer eventually will leak. Valves, fixture controls, cleanouts, and compression pipe fittings must not be covered by a wall or floor surface in case you need to work on them in the future. If necessary, access panels can be used to allow for easy accessibility. When changing pipe materials, use the correct transition fittings. Without a dielectric union, shown in the picture, the joint between galvanized and copper pipe would quickly corrode. Use the approved fitting when changing from plastic to copper, cast iron to plastic, and ABS to PVC. Codes call for cleanouts at various points so drains can be easily augered in case of a clog. Facility staff will need to be familiar enough with their plumbing systems to identify the most effective points to clear a clog. We will now review the various methods of making piping connections. Fitters work with a variety of pipe and tubing materials, including several types of steel, copper, iron, aluminum, and plastic. Pipe fitting is not plumbing. The two are related but separate trades. Pipe fitters who specialize in fire prevention are often called sprinkler fitters, another related but separate trade. Steel pipe is sometimes joined using threaded connections, where tapered threads are cut into the end of the tubing segment. Sealant is applied in the form of thread sealing compound or thread seal tape, also known as Teflon tape. and it is then threaded into a corresponding threaded fitting using a pipe wrench. Beyond domestic or light commercial settings, steel pipe is often joined by welding or by the use of mechanical couplings made by companies such as FIXTURE or Grinnell that hold the pipe joint together via a groove pressed or cut into the ends of the pipes. Copper tubing is most often used for supply of hot and cold water and as refrigerant lines in HVAC systems. There are two basic types of copper tubing, soft copper and rigid copper. Copper tubing is joined using flare connection, compression connection, or soldering. Copper offers a high level of resistance to corrosion, but it's becoming very costly. Solder fittings are smooth and easily slip onto the end of a tubing section. The joint is then heated using a torch, and solder is melted into the connection. When the solder cools, it forms a very strong bond which can last for decades. Solder-connected rigid copper is the most popular choice for water supply lines in modern buildings. In situations where many connections must be made at once, such as plumbing of a new building, solder offers much quicker and much less expensive joinery than compression or flare fittings. The term sweating is sometimes used to describe the process of soldering pipes. Compression fittings use a soft metal compression ring or thermoplastic ring which is squeezed onto the pipe and into the fitting by a compression nut. The soft metal conforms to the surface of the tubing and the fitting and creates a seal. Compression connections do not typically have the long life that sweat connections offer, but are advantageous in many cases because they are easy to make using basic tools. A disadvantage in compression connections is that they take longer to make than sweat and sometimes require retightening over time to stop leaks. Crimped or pressed connections use special copper fittings which are permanently attached to rigid copper tubing with a powered crimper. The special fittings, manufactured with sealant already inside, slide over the tubing to be connected. Thousands of pounds force per square inch of pressure are used to deform the fitting and compress the sealant against the inner copper tubing, creating a watertight seal. The advantage of this method are that it should last as long as the tubing. It takes less time to complete than other methods. It is cleaner in both appearance and the materials used to make the connection, and no open flame is used during the connection process. The disadvantages are that the fittings used are harder to find and cost significantly more than sweat-tight fittings. Flare connections require that the end of a tubing section be spread outward in a bell shape using a flare tool. A flare nut then compresses this bell-shaped end onto a male fitting. Flare connections are a labor-intensive method of making connections, but are quite reliable over the course of many years. Some other materials that can be used in piping systems are aluminum, glass, and plastic pipe. Each are used in specialty situations, and each have their own ways of making connections. Next, we will go over how to use sewer augers. Push the flexible cable into the drain and crank the auger clockwise until it stops, then push forward. The auger may feel like it has grabbed something, or it may just break up the clog. If it feels like it grabbed something, pull it out to check. If it gets stuck, gently turn the crank back and forth or push and pull the tube, but never force the auger or you may break the toilet porcelain. After breaking up the clog, use the plunger again to make sure the obstruction is cleared. Once you're sure it's okay, flush the toilet. Next, we will go over how to size various piping materials. Measure the outside diameter of the pipe. Use a tape measure or other measuring device to determine the pipe diameter. For male and female pipes, make sure the outside diameter is measured from around the outer edges of the thread. You can measure the exterior diameter in millimeters or inches, as pipe sizes are available in metric sizes as well as standard English sizes. Obtain a thread comparison table which contains the schedule numbers set by the American National Standards Institute. These tables can be found online by performing a search. Use a comparison table that matches the exterior diameter with the schedule number. An example of a schedule number is NPS 36. Match the exterior pipe diameter to the closest measurement and read the corresponding pipe size. Choose a pipe fitting that corresponds to this pipe size. Pipe fittings go over the pipe, so it is the external diameter that is important as the fitting goes over the pipe. Match the connector type, as there are pipe connectors specifically for male threaded pipe ends and female threaded pipe ends. Some pipe connectors will not use threads, but will be marked as a female slip fit or male slip fit. Copper supply lines vary according to wall thickness and diameter. Copper pipe manufacturers designate copper pipe's wall thickness by an identifying letter. For example, type K, copper tube, has a relatively thick wall, and type M has a relatively thin wall. Next, we will review how to read fluid pressures. In this example, we are showing a pressure of 160 psi, pounds per square inch. You know that we are reading pounds per square inch by the indication on the bottom of the meter. The largest increments are indicated with a large black line, but we can also deduce that each smaller line is equal to 4 psi by taking the difference of the two closest large numbers, subtracting them, and then dividing by the 5 parts. We will now go over the letter codes for copper thickness, which was briefly touched on earlier in the presentation. There are 4 standardized types of copper thickness: K, L, M, and DWV. The letters indicate, in part, the relative thickness of the pipe wall from thickest to thinnest. The actual wall thickness depends on the size of the pipe. The letter codes also relate to the color of the printing placed on the side of the pipe, which helps to identify it. Type K is green, type L is blue, type M is red, and DWV is yellow. Type L pipe may be referred to as blue. Type M is often referred to as red. Next, we will cover pipe schedule. Pipes are designed to carry fluid. Therefore, their internal diameter is their critical dimension. This critical dimension is referred to as the nominal bore, abbreviated as NB. Obviously, for pipes containing pressurized fluids, the wall thickness, and by implication, the pipe strength, is important. Wall thickness is expressed in schedules, referred to as pipe schedules. In pipe terms, schedule indicates the wall thickness. The thickness of the wall is responsible for the pressure capacity of the pipe. No matter what schedule of pipe is used, the outside diameter is standard and the inside diameter decreases as the schedule increases. Because the outside diameter of fittings stays consistent as the pipe wall thickness increases, fittings work with any schedule. Next, we will review backflow preventers and how they are used. Basically, it only allows water to flow through the valve in one direction. When no supply is present, the valve automatically closes so that water on the other or downstream side of the valve cannot pass through the valve and contaminate the potable supply line. Next, we will cover the basic function of plumbing piping, including vents, traps, potable supply, and some others. The purpose of the piping in a plumbing system is to transport fluids and gases effectively and appropriately. The venting system, or plumbing vents, consists of pipes leading from waste pipes to the outdoors, usually through the roof. Vents provide a means to release sewer gases outside instead of inside the house. Vents provide a way to equalize the pressure on both sides of a trap, thereby allowing the trap to hold water, which is needed to maintain effectiveness of the trap. Every fixture is required to have an internal or external trap. Double trapping is prohibited by plumbing codes due to its susceptibility to clogging. With exceptions, every plumbing fixture must have an attached vent. In accordance with national and state plumbing codes, traps have to be placed under just about every plumbing fixture, which includes sinks, bathtubs, and toilets. These devices trap a small amount of water at their bottoms. It's the water in each fixture that acts as a barrier to smells, gases, insects, and bacteria. Because P-traps are designed to be low points under a sink or other fixture, they can often become a collection point for hair and other objects. Potable water is water which is fit for consumption by humans and other animals. The plumbing related to potable water serves to deliver this product to where it is needed. Obvious examples of this are sinks, showers, and toilets. This would also include plumbing that delivers water to various water treatment devices, such as reverse osmosis, deionized water, and soft water are just a few examples of this. We will now go over the test questions covered in the MECH test preparation manual. You can follow along in the booklet as there are some complicated diagrams in the manual that are referenced in this review. CAT test question 1. Copper, iron, and plastic pipe. A, all handle the same pressure. B, each have the same thicknesses. C, all have the same outside diameter measurements. And D, each have different methods of connecting. Answer D is the best answer here. Answer A is not correct because copper and iron will handle much higher pressures than plastic pipe. Answer B is not correct because iron and plastic pipe will typically be much thicker than copper pipe. Answer C is not correct because outside diameter is different for each type of material. For example, a 2-inch pipe in PVC has an outside diameter of 2.375. In copper, it has an outside diameter of 2.125. And in iron, it has an outside diameter of 2.5. For additional information, you can go to the websites shown on the screen. CAT test question 2. The tie-in test includes A, the determination of leaks and flow testing, B, testing for leaks and purifying the new pipe run, C, flow testing and volume measure, and D, volume measurement and water clarity. Answer B is the best answer here. Answer A is not correct because though the tie-in test does test for leaks, it does not perform flow testing. Answer C also has flow testing in the answer, so it is incorrect. Answer D is not correct because the tie-in test does not include volume measurement or water clarity. CAT test question 3. Pipe runs are measured by A, using the correct scale and estimating from the prints, B, visually inspecting the new run's path before ordering pipe, C, both A and B, or D, using a tape measure. Answer C is the best answer here because both answers A and B are correct, but answer D does not work because tape measures are often not long enough to measure long distances. CAT test question 4. If copper pipe needs to be ordered, water pipe size is specified by A, actual inside diameter, B, nominal inside diameter, C, outside diameter, or D, wall thickness. Answer B is the best answer here because water, a fluid, is specified to be transported, in which case the most important property is the capacity or the inside diameter. Since the outside diameter of a single nominal pipe size is kept constant, the inside diameter of a pipe will depend on the schedule or the thickness of the pipe. The schedule and the actual thickness of a pipe varies with the size of the pipe. CAT test question 5. Alignment of the pump coupling. A, affects the life of the coupling. B, changes the output of the pump. C, reduces amperage. Or D, is a safety consideration. Answer A is the best answer here because a misaligned coupling can cause excessive wear on the coupling, hence shortening the life of the coupling. Answer B, C, and D are not the correct answers because the primary purpose of couplings is to join two pieces of rotating equipment while permitting some degree of misalignment or end movement, or both. Pump output and amperage should not be affected, and safety should be gained by a shaft guard. CAT test question 6. Packing in a pump seal is A, made of brass, B, uses a nylon rope to seal the shaft, C, uses friction to reduce the wear of the seal, D, is compressed with a jam nut. As seen in the drawing, answer D is the best answer here. Packing in a pump seal is compressed with the jam nut. CAT test question 7. Here you can refer to the images in your MECH preparation manual. Select from the pictures the most appropriate sealing hanger for a 2-inch galvanized pipe that carries wastewater and must be attached to a concrete ceiling. Refer to the images in your MECH preparation manual. Answer A is the best answer here because the hanger allows for securing to the ceiling with anchors. Answers B, C, and D do not allow for attachment to concrete ceilings. CAT test question 8. When tightening a new, properly threaded pipe and fitting, the connection is currently correctly tight when A, half of the thread is showing, B, one thread is showing, C, 1.5 of the threads are showing, or D, 2 threads are showing. Answer D is the best choice here, as indicated on the image on the screen. 2 threads allows for a wedging effect from the tapered threads to ensure the pipe and fitting remain secure. CAT test question 9. If it is necessary to shut down a plumbing supply run, the entire plumbing supply system should be turned off. B, affected staff must be notified. C, emergency water needs to be used. D, the non-potable water should be shut down. Answer B is the best choice here. Answer A is not the best choice because a supply run can be secured without shutting down the entire system. Answer C is not always a requirement, especially if work is done during off hours or in buildings that do not have occupants. Answer D is not the best choice because the supply run may be on a potable source, and would therefore not affect the activity. CAT test question 10. To shut down a water supply system, A, the water run supply valve is turned counterclockwise until snug, and then tagged and locked. B, the water run supply valve is turned clockwise until snug. C, turn off the city water main to the building. Or D, either B or C. Answer D is the best choice here because both answers B and C are correct. Answer A is not correct because valves are opened by rotating the handle counterclockwise. Comp test 11, question number 1. The symbol below is for A, circuit breaker, B, foundation post, C, ceiling fixture, or D, floor drain. Answer D is the best choice here. Symbols for the circuit breaker and the ceiling fixtures are shown on the screen. Comp test 12, question number 1. Refer to the diagram in your MECH preparation manual. If water had backed up on the floor through the 3-inch floor drain, you would begin augering the 3-inch line through A, the vent, B, 3-inch cleanout, C, the floor drain, or D, the 4-inch line. Answer B is the best answer here. The 3-inch cleanout provides for direct access to the clog and is the correct method for augering the 3-inch line. Comp test 13, question number 1. Most valves are named for the A, overall outside valve shape, B, internal closing configuration, C, type of service intended, or D, material from which they are made. Answer B is the correct choice. Answer A is not the best choice because many valves have similar outside valve shapes but differing internal configurations. Answer C is not the best choice because valves can have multiple types of service, and answer D is not the best choice because valves can be made from a multitude of different materials. Comp Test 14, question number 1. Match the symbols in the same order as the following types of connections: flanged, welded, bell and spigot, soldered. Answer A is the correct answer here. Answers B, C, and D are all not in the correct order. Comp Test 15, question number 1. Water hammer in a water piping system occurs when the A, line has too many turns, B, flow is suddenly stopped, C, corrosion gets too thick, or D, steam condenses too rapidly. Answer B is the best choice here. Water hammer is caused when liquid flow is suddenly stopped and is not caused by too many turns, corrosion, or steam condensing too rapidly, which are all answers A, B, and C. A, C, and D. Answer B is the best answer here. Comp Test 16, question number 1. What should you do as the first step when removing a steam trap strainer for cleaning? A, be sure that it's dirty. B, have a replacement ready. C, shut off the line. D, be sure there is enough line pressure. The best answer here is C. When removing a steam trap, the first step that should be taken is to shut off the line. Answer A is not the best answer because a facility staff member will not know whether the trap is dirty until the trap is disassembled. Answer B may not be needed, and answer D is not correct because line pressure is a safety risk. Comp Test 17, question number 1. Which of the following wrenches is used on steel pipework? A, a chain wrench, B, strap wrench, C, Stilson wrench, D, crescent wrench. As shown on the screen, answer C is the best answer here. A Stilson wrench is the best application when working on steel pipework. Comp Test 18, question number 1. A pressure relief valve on a water heater, A, keeps the tank from overheating, B, is not required, C, creates necessary pressure, D, is installed at the discharge drain. Answer D is the best answer here. Answer A is not correct because a pressure relief valve keeps the tank from overpressurizing. Answer B is not correct because relief valves are required on water heaters, and answer C is not correct because relief valves are used to relieve pressure, not create it. That completes our study guide.